In this video, we quickly learned how to use the built-in hypothesis testing function for the significance of a correlation. So that's the LinRegTTest function in the TI-84. And the context here is a little set of 12 ordered pairs where our X variable is the hours spent studying for a midterm exam, and our Y variable is the score on the midterm. And we're testing for a significant correlation with a significance level of alpha equals 0.05. So in a hypothesis test for the significance of a correlation, the null hypothesis is going to be that there's no correlation at all in the larger population. So we say the null hypothesis is that rho equals 0. That little Greek letter rho is the population correlation coefficient. And our alternative hypothesis is that the population correlation coefficient differs significantly from 0. So when we run the test, we'll get a p-value out of it, and the interpretation there is that it's the probability to see a correlation coefficient this far or farther from 0, based on the assumption that the null hypothesis is true. So we need to enter the data in our calculator. So to get that done, we hit Stat, and then Edit. And I've actually entered the data already just to save some time. So to do this hypothesis test, we hit Stat, we go over to Tests, and we're going to arrow down to LinRegTTest. So we hit Enter on that and make sure that we have rho not equal to 0 highlighted here as our alternative hypothesis. So we're doing a two-tailed test, and we select Calculate, hit Enter, and a bunch of stuff pops out here. I do want to point out that a t-score pops out because behind the scenes, this is actually a two-tailed t-test. And if your teacher uses the critical value approach to hypothesis testing, you're going to need that t-score. But right now, I'm just focused on this p-value, which turns out to be about 2.13 times 10 to the negative 12th. So that means there's practically a 0 probability to see a correlation this strong if the population has a 0 correlation coefficient. So with the p-value being practically 0 here, of course that's less than the 0.05 significance level, and we reject the null hypothesis. So we conclude that our correlation differs significantly from 0. In the next video, we'll take a closer look at the machinery behind this hypothesis test, because what's really going on behind the curtain is a two-tailed t-test. I'll post a link to that video at the upper left, and I'll see you there.